What is going on, everybody? It's Mr. Gustin. I'm not in the chemistry classroom. I'm in my physics classroom, but we are doing some chemistry today. We're doing some chemistry math. It's a little stoichiometry review, kind of, but we're also introducing and recapping what we call solution stoichiometry or molarity. So molarity is this new concept, and molarity, as we talked about before, is kind of the ratio of chemical dissolved in water. You're going to hear students come walking in because students eat lunch in here. So come on in, Ratasha. We're filming a chemistry video. Come on in. You just got to sit over there and watch me do some chemistry. Ratasha, say hi, dude.
Hi.
Don't just walk by. Say hi.
Hello?
Ratasha is a chemistry survivor. She had chemistry last year with me. She survived and is doing okay. But we were talking about molarity, and molarity is a ratio of moles dissolved in solution or dissolved in water. It's a new way we can keep track of chemicals, especially as we do things like double displacement and single replacement reactions. So our equation for molarity sits right here. Molarity is equal to the number of moles divided by liters. It's just a ratio, just like grams per mole is, just like our mole to mole ratios are. It's just another ratio we can use in our stoichiometric process. Okay, so let's look at an example problem I have behind us where we can actually calculate molarity. Here's the first one. Got 160 grams of potassium nitrate, and I'm making a 2 molar solution. So I've got grams, and I'm making a concentrated solution, 2 molar solution, and it asks what volume of the solution can be made. So if I think about this, and I think about my molarity equation, I know I need to figure out the number of moles from grams because molarity is related to moles and liters. Grams isn't going to cut it. So my first step here is to convert potassium nitrate from grams into moles. And if you remember, we go ahead and use our periodic table to find the molar mass of potassium nitrate. On the periodic table, my molar mass is 101.1 grams. I use my ratio in the appropriate way. So I end up dividing 160 grams by 101, and this tells me the number of moles of potassium nitrate. So I end up with 1.58, and you at home can go ahead and punch this in your calculator and figure it out on your own. The last question, though, is what is the volume? Because that's the question I had to begin with, was what volume of solution can be made if I use 160 grams? So if I have 1.58 moles, how much of that 2 molar solution can I make? And we use our mole over liter equation for molarity. We find that 1.58 moles over some volume, x, is equal to 2 molar. We solve for x, do some cross multiply divide thing, and we end up with 0.79 liters. This is the amount of potassium nitrate that I can make if I only have 160 grams of potassium nitrate, and I want to keep that concentration of the solution at 2 molar. This is something we've been covering, this molarity calculation. Something we haven't necessarily been covering is using that molarity calculation in a stoichiometry problem. So for example, now I'm not just curious about the concentration of something, I'm actually curious about how much product I can make, how much reactant might get used. So here's an example. I've got magnesium. Magnesium solid in a single replacement reaction reacts to hydrochloric acid and it produces hydrogen gas and magnesium chloride aqueous. It's ions in water. My question is how many liters of a 0.75 molar solution will react with 12.25 grams of magnesium? So I'm looking at, I know my magnesium amount. I'm trying to react all of this magnesium. So my question is how much HCl will I need to completely react away my magnesium? So I'm keeping my stoichiometry fixed in the reactants. I'm over here on this side. I'm not looking for products. I'm just trying to figure out how much HCl I'll need. So first things first, I know that anytime there's a reaction involved, I need to get my numbers into moles. Moles are my converting units, so I want to go over to moles. What do I start with? I start with 12.25 grams of magnesium. That's where I start. I start here. I want to get here. I'm in grams of magnesium right now, so let's get this thing converted over into moles of magnesium. I already went ahead because I knew what I was going to do, and I found my molar masses. So magnesium has a molar mass of, I want to go to moles of magnesium, so that's on top. Grams go on bottom. Magnesium is 24.3 grams, 24 0.3 grams in 1 mole. So I can go ahead right away and convert over into moles. That's step 1, convert to moles. 12.25 divided by 24.3, I get an answer of 0.504 moles. And over here, I'm going to keep track of my steps, the steps that I take. So the first step I took was I found moles. However I have to do it, I want to find, I shouldn't say found, these are steps. I should say find number of moles. That's my first step, okay? Done. Half a mole. I got half a mole of magnesium. Now I'm converting from magnesium over to HCl. I want to find how much HCl I need. So that next step is going to be to convert from Mg to HCl. I have, what's up, Kat? Hey. 0.504 moles of a Mg. And I want to find HCl. HCl is what I want. Mg is what I have. That goes on bottom. So I'm converting. I look at my balanced equation. My balanced equation shows me I have 2 moles of HCl for every 1 mole of magnesium. So this is my ratio. I balance it out. I find that I actually have somewhere near 1 mole. 1.008 moles of HCl. Basically 1 mole of HCl. So what's my second step? It was find moles. My second step was convert moles to moles. Using my balanced equation. Now, I gave you the balanced equation. This time I didn't ask you to predict products. I didn't ask you to balance anything. But in the future, you know I'm going to ask you to do that. So be aware. Lastly, the question asks how many liters. Now I've finally converted myself over into chemical HCl, into hydrochloric acid. I want to figure out how many liters of HCl I need. This is where molarity comes back into play. Again, we had this written over on our sideboard that molarity is equal to moles per liter. I'm going to need to use my molarity equation now. So it tells me that I have a 0.75 molar solution. I know that I have 1.008 moles in that solution, and I'm trying to find my liters. So I cross multiply and divide. What do I end up with? 1 divided by that there. I end up with 1.33 liters of HCl. This is my answer. Okay, this is my answer. My third step going here is after I've converted from moles over, I use moles to find, and it could be liters, it could be grams, it could be concentration or molarity, etc. It could be any one of these things, right? Once I have moles of product or moles of the chemical I'm solving for, once I have that, my last step is go find the last thing. I may need to use molarity, I may need to use molar mass, I may need to use something. But this is how I go ahead and solve this problem. So now we've got steps. Okay, we've done the molarity calculation. We did our first calculation here. Now we've got 3 steps to use, and I've shown you how to do it. We're going to do one more. And this last one, if you think you've got it, I challenge you to pause this video and try it on your own first. Then come back and look at my solution. If you're still stuck and your head is still spinning, go ahead and watch the whole thing. But truthfully, I'm not going anywhere. It's YouTube, right? Just pause the video, try it on your own. When you get stuck, hit the unpause button, and let's go. But we are going to use my steps, so pause it. If you didn't pause it, you're still here, fine, we'll do it, okay? We'll do it, Rataja and Kat. Kat, I'm filming a video in case you didn't notice.
I figured that out.
You figured it out?
Yeah.
Okay. Let's see this one. This one says how many grams of precipitate. So we're different, right? We're not starting in grams. We're actually starting with a solution. We have a solution of liters and moles over here, or concentration liters. So we're starting differently, but the step 1 is still the same. So we start with a 0.025 liters of a 2 molar sodium iodide solution. That's this chemical here. And we're trying to figure out how many grams of precipitate are formed. Well, precipitate means solid chemical form. So we're converting from sodium iodide over into lead iodide. And step 1 is find number of moles. How can I find number of moles? Well, I'm given molarity. I'm given liters. Moles is in that equation. So here we go. Let's do molarity. I'll write my equation out for us. Moles over liters. And this is going to be moles of NaI. Will give me liters of NaI. And this is molarity of NaI. Let's plug these things in. What's my molarity? Is 2.00 molar. My moles are what I'm solving for. Come on in.
Hi.
How can I help you?
I got 2 passes.
2 passes?
For 2 of your sit-ins.
Oh my goodness. They are not in here right now because it's late arrival.
I see.
No problem. All right, thank you.
Bye.
It's an FNP, that's why.
Sorry?
It's an FNP, it's an advisory, that's why.
Oh.
Okay, thank you. Now I bet you we shouldn't pause it now. Now we're doing, it's fun. This is real life video stuff, kids. What was I saying, Rataja? Oh!
What?
I'm filling out my equation. That's what I'm doing. I'm filling out my equation.
Okay.
I've got concentration, 2 molar. I'm trying to find moles of NaI, and my liters are 0.025 liters of sodium iodide. So step one, find moles. Let's do it. 2 times cross multiply. I get 0.050 moles of NaI to start. Step 1, check. I found moles. Step 2 is convert using the mole to mole ratio in the balanced equation. So I've got 0.05 moles of NaI. I want to convert over into PbI2 because that's what the question's asking me, how much precipitate forms. What's my ratio? There are 2 moles of NaI. 2 moles for every 1 mole of PbI2. I do my math, and I find that this is equal to 0.025 moles of PbI2. Step 2, done. Last step says use this number of moles to find liters, grams, molarity, etc. And in this problem, I'm asked to find how many grams there are. So given the number of moles, trying to find grams in my head, I'm thinking I'd better use molar mass. So 0.025 moles of PbI2 times the molar mass, which is PbI2. Don't do PBI. Some of you in class doing PBI. Stop, that's PbI2. PbI2 is 461 grams per mole. Grams, mole, I want grams on top because I'm trying to find the grams, so grams go on top. That's 461 grams per mole. What do I end up with here? Kat, what do I end up with? I'm just kidding. Kat's not paying attention. 0.025 times 461. Just like Rataja said, 11.5. Nice job, Rataja.
Thank you.
11.5 grams of PbI2. When you're asked the question, how much precipitate should I expect to make in this reaction, your answer had better be about 11.5 grams. Folks, this is solution stoichiometry. It's molarity, it's concentrations, and then we use those concentrations and molarity in classic old school stoic problems. You better be ready for it. We got some labs coming up. If you got questions, you drop in the comments, you send me an email. Until next time, see ya!